In this video, I'll be covering question 4, part B from the 2018 AP Calculus AB free response no calculator allowed portion of the exam. I cover parts A, B, C, and D all in their own individual videos, so if you want to see those other solutions, please check out my other videos. Okay, so B here is kind of a classic little lead-in to a setup that you should be prepared for heading into this test. They want us to explain why there must be at least one time t in this given interval right here, such that the derivative has this value. So kind of bells and whistles should be going off at this point that, they're not asking me to actually find that specific value where it happens. They don't even care about that. They just want me to show that it could be that. Well, then they want us to show that a derivative could have a value. Then 99 times out of 100, what that's telling us is we need to apply the mean value theorem. And what the mean value theorem says is if I get two things, if I have a function that is continuous on a closed interval from a to b, and it has to be both of these things, and that function is differentiable on the open interval a to b. If that happens, then I get to draw this conclusion. Then I get to say that there is some point C that lives between A and B such that the derivative at that point is equal to the slope between those endpoints. So f of b minus f of a over b minus a. Essentially, that's a slope equation. That's like your classic y2 minus y1 over x2 minus x1 going on there. And so when we come back and do this, if we can show them that these two things are true, then we are guaranteed our conclusion, which conveniently just says that a derivative is going to equal the slope between those two endpoints. So as you come back over here, kind of the trap I think on this problem is the fact that you see the 2 and the 10, and you say to yourself, oh, I should be using those for my A and my B right here. What you kind of have to do is you've got to be doing some quick little mental math at some level and saying, what's my slope between 2 and 10? Well, if I had 2 here and 10 here, those are the y values that go with them. So I'd be looking at the point 2, 1.5, and then 10, 15. And if I do just a quick slope problem, you almost don't even need to fill the whole thing out. You'd say 15 minus 1.5 over 10 minus 2. Well, that's definitely not going to equal 2 when I simplify it down, right? I'm going to get 13.5 over 8. That doesn't equal 2. So those aren't the 2 points that I'm looking for. And so what you're looking at now is some combo of these other points in between here. Because notice also the trap here is that these don't have equals on them. So you really cannot use those two values anyways, and you're looking for stuff in between. So you'd have to kind of, again, do some quick mental math on here as best as you can. And you'd say, I'm really looking for, like, when does the change in y over the change in x, when does that equal to? After some trial and error, what you would probably hopefully come to the conclusion is these are my 2 points here. So if I have the point 3, 2, and I have the point 5, 6, there's my x1, y1, x2, y2. If I do that slope formula, y2 minus y1 over x2 minus x1, I get 4 over 2, which equals 2. So that's the magic that I'm hoping to have happen, that my slope is going to equal the value that we cared about here, which is 2. So I found my interval, and now I have to kind of go backwards from that and explain to them why I get to use it. And so what you would say is, because h of t is differentiable on the open interval 3 to 5, and you don't just get to randomly say that. You get to say that because they tell us up at the top here that h is a twice differentiable function, so that we know for a fact that it's differentiable. So you don't get to just randomly pull that out of the air. It says it up there so you can draw that conclusion. Because h of t is differentiable on 3 to 5, h of t is also continuous on that interval from 3 to 5. So the mean value theorem applies. That's kind of our rationale for them. We have to be able to tell them that we're allowed to use the mean value theorem. And what the mean value theorem says is that there is some derivative. So there's going to be some h prime of c such that, and we're filling in this half here. So this is my a and this is my b, and we just have to use their language of h. So you would say h of 5 minus h of 3 over 5 minus 3. So we know there has to be some derivative value that equals the slope between those endpoints. And then we bring back together the math using those 2 points. So at h of 5, we know that our value was 6. At h of 3, we know our value was 2. And then on the bottom, we have 5 minus 3. So out of there, we get 4 over 2, which equals 2. So that guarantees us now that there is some value c in the interval 3 to 5 such that h prime of c has to equal 2. So we have guaranteed them that there is at least one time t such that that value would equal 2. So again, this is a telltale sign set up on here that, when they're wanting us to confirm that something exists and the thing they want us to confirm is a derivative value, 99 times out of 100 you have to go through this mean value theorem. And to get to that mean value theorem, you always have to tell them why you're allowed to apply it. So from there, we end up getting out 2 points on this problem, 1 point from getting our conclusion here using our formula, and then 1 point from telling them why we got to do it using the mean value theorem. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.